All right, so we're told we're given this definite integral. We don't know this power n, but we know it's a constant, and this whole thing equals 100. I'm going to show you in just a few minutes how easy this is to actually solve. Let's think for a second how we would normally integrate x to the n dx, right? Where n is just some any constant. Well, you would just get x to the n plus 1, because you're adding 1 to the power, and then you're dividing it by n plus 1, and then you add a c at the end. Okay, so with that being said, now let's go to our definite integral knowing what this part is. And for the definite integral now, we have 100 equals the result of integrating x to the n, right? So we're going to have x to the n plus 1 all over n plus 1. Now I'm going to drop the plus c here, and you tell me in the comments below why I can do that. But now we simply will evaluate this using the limits of integration from 0 to 100. Super important. These are what you're going to plug in for x, not for n. And we're going to try and solve for what n is. Okay, so this is going to look like just some simple algebra, right? Because you will get 100 equals 100 to the n plus 1, because we're plugging in the upper limit of integration first. And then you subtract it by plugging in that 0, which is the lower limit of integration. And this is kind of sweet, right? Because that's just 0 raised to a power. And we're ninjas here on this channel, right? So we can just karate chop this term because it goes away. And speaking of which, if you're enjoying this, by the way, smash that like button for me. And if you want to be even quicker at this mental math stuff, I've got a cool game, Number Ninjas. Check it out in the description below. It's free. So now we're going to be left with 100 equals 100 raised to the n plus 1 all over n plus 1, right? So remembering natural logs and logarithms, you have 100 on both sides here. I know 100 is a power of 10, so what makes it really easy is if I use log base 10 and take the log of both sides, giving me log of 100 equals log of 100 to the n plus 1 all over n plus 1. If you're thinking ahead, you can also see that we can use a special property of logarithms here, right? Now for log of 100, that's just going to be 2, right? Because 10 squared is 100. And then for the right-hand side, I can split this logarithm up as a difference of 2 using a special property of logarithms. So you'll get log of, 100 to the n plus 1 minus log of n plus 1. Now, there's another property of logarithms we can use here because we have this power within a logarithmic expression, right? So you can just bring it out in front. So you'll get 2 equals, make sure to use parentheses for your order operations. You'll get log of 100, and you're going to see that's going to go away really nicely, minus log of n plus 1. Log of 100, again, is just a 2. So this will simplify to 2 equals n plus 1 all times 2 minus log of n plus 1. And now I'm going to multiply through that 2, giving me 2 equals 2n plus 2 minus log of n plus 1. And so now we can simplify the 2's on both sides by subtracting them. Now I'm going to have 0 equals 2n minus log of n plus 1. Uh-oh. We've got this linear term here and a logarithmic term. Usually when they're in the same equation, it's not so pretty, right? Let me just go ahead just for giggles and just add the log term to both sides, giving me log of n plus 1 equals 2n. And what I like to do here is I like to tell myself, okay, let's think about some trivial values of n that could work, like 0, 1, -1. Could 1 work here? Well, you get log of 1 plus 1, which is log of 2 equals 2. That doesn't really make sense. It doesn't work. How about a 0? So log of 0 plus 1, which is log of 1, that's going to give you 0, right? Because 10 to the 0th is 1. And then on the right-hand side for n equals 0, you get 0. So 0 equals 0 tells us that n equals 0 is one of the solutions. Now, your homework question, and you probably need to use a calculator for this one for an approximation, find the other values of n that works here. And if you want more practice before your next exam with integration, check out this video.